All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you should have x plus 6 times x plus 2. For the math knowledge question, they tell us that this angle is x plus 40 and this one is 2x plus 20. And we want the two lines to not be parallel. So if they were parallel, x plus 40 plus 2x plus 20 would equal 180. And if you combined your like terms, 3x plus 60 would equal 180. So 3x would equal 120 and x would equal 40. So we're not going to pick just A because it wants to know what are all of the values that it would make it not parallel. So the other thing that we have to check for is where our 2x plus 20 and our x plus 40, we have to make sure that those are positive angles. So if 2x plus 20 has to be greater than 0, 2x would have to be greater than negative 20, so x would have to be bigger than negative 10. And then if this one had to be positive, x plus 40 would have to be greater than 0, so x would have to be greater than negative 40. So the one that has fewer numbers would be this one. Okay, so that would be what we're going to be looking for. So we're not doing A, B isn't right, C could be right, but it doesn't have this 40. And we know that at 40, it's going to be equal to 180, which means it'll be parallel lines. So we don't want that one. But E is the one we're going to pick because it goes from negative 10 to 40, and then it goes from 40 to 80. And the reason that we're going to go from 40 to 80 is if you look over here, one of these could be less than 180, and this one could just be almost 180, and this one could be almost 0. And so if this one was less than 180, 2x would be less than 160, and x would be less than 80. And so that's where that 80 comes from. So that's how you can work through the math knowledge question. You could also just pick some random numbers and see which range worked, if you would rather do it that way. So we're looking at lesson 27 today. We're looking at two-column proofs. So hopefully after this lesson you'll understand a little bit more about how two-column proofs work. So let's start with an example. This is what a two-column proof is going to look like, and we're going to go over it a little bit more in a minute. But we want to practice doing the justifications or the reasons for our proof. So they tell us that we are given non-collinear points A, B, and C, and we want to prove that A, B, and C are coplanar. So the first reason, when we were doing our algebraic proofs, what did we always start with? We always started with the given. And that's going to be your reason here. Number one, it's your given, and it's up here. And it says given is this, which is what the statement says here. So your first thing is always your given. And then it says line AB contains points A and B. The reasoning for that would be 2 points determine a line. And then for step 3, line BC contains points B and C. So what could be the reasoning for that one? Again, 2 points determine a line. So both of those have the same reasoning. For 4, line AB and line BC are contained in a plane. The reasoning for this one is going to be 2 intersecting lines are contained in one plane. And we know that they're intersecting because they both have point B. And so if you have two lines that intersect, they are contained in one plane. And then if these are contained in one plane, that means that A, B, and C are coplanar by the definition of coplanar. So right off, when you start doing two-column proofs, you're probably not going to be able to do them 100% by yourself. You're going to have to practice at them. Eventually, you will get to where you have to do them completely by yourself. On the first test that two-column proof shows up on, you only have to do the justifications. So don't stress about it too much. Just keep practicing on your homework, and these are going to get easier the more you do them. So let's look at this one. We have another example where we want to fill in just the reasons. So it gives us a figure, and it says we have exterior angles 2, 4, and 6. And we want to prove that 2, 4, and 6 add up to 360. So when we go to our reasons, it tells us the triangle with exterior angles 2, 4, and 6. Now, what always goes first for your reason? You're always going to put given for your first one because that's what is given right here. You always want to start with your given. From here, angle 2 equals angle 3 plus angle 5. Angle 4 equals 1 and 5. And angle 6 equals angles 1 and 3. Anyone know the theorem that goes with that one? It's the exterior angles theorem. Okay, so from here, we can say angle 2 plus angle 4 plus angle 6 equals 2 times angle 1, angle 3, and angle 5. And you may be wondering where this equation came from. If you add these three equations, you get 2, 4, and 6 on one side, and on the other side, the right side, you get 2 angle 1s, 2 angle 3s, and 2 angle 5s. And so the reasoning for it would be addition of equations. Okay, and now here, angle 1, angle 3, and angle 5 equal 180 degrees. Well, how do we know that 1, 3, and 5 add up to 180? That's from the triangle angle sum theorem. Those three have to add up to 180. And so then, going back to this equation here, we can plug in, instead of angle 1, angle 3, and angle 5, we can say that equals 180. So that's going to be substitution. Property of equality. And then going from this step to this step, what do? All that's changed is we multiplied 2 times 180 to get 360. So you can either say simplify or multiplication property. Either one of those would be fine with me. Okay? So that's how that one would work. So now we're going to look at the parts of a two-column proof. The first part is going to be your given statements. That's the information that's provided. You're also going to have a prove statement, and that's what you are trying to prove whenever you finish your proof. You're going to have a diagram, and that's usually a sketch that summarizes information. Sometimes you have to draw the diagram yourself based on the information they give you. It just depends on the problem. Sometimes they give you a diagram and sometimes they don't. You also have the statements. Those are the ones that are written in the left-hand column. And then you're going to have your reasons, and those are usually postulates, theorems, definitions, properties, and those are in the right-hand column, and those are your justifications. So those are the 5 parts of a two-column proof. So we're going to look at an example, and there are no statements or reasons filled out. We are trying to prove theorem 10.1. If two parallel lines are cut by transversal, then alternate interior angles are congruent. So the best way to practice these is to just try them by yourself. I'm not going to make you do this one by yourself, but on your homework, the best way to get these right is to just keep practicing them. If you don't attempt them on your homework, then it's going to be impossible to get them right on your test. So don't just look at it and go, I'll never get this. I can't do it. This is too hard. You have to practice at them. They are not too hard. They just take time. They take practice. So the first statement that we are going to start with is always the given, which is S is parallel to T. And so the reason would be given. And so that is the very first thing that you're going to write. From there, if these two lines are parallel, we are trying to prove that the alternate interior angles are congruent, angle 2 and angle 3. So we can't just go, since they're parallel, these two angles are congruent. We have to prove it using some other method. So one thing that we can say is that angle 1 and angle 3 are congruent. How do we know that angle 1 and angle 3 are congruent? It's from the corresponding angles postulate. So that would be your reasoning for that one. We also know that angle 1 and angle 2 are congruent. How do we know that angle 1 is congruent to angle 2? That's from the vertical angles theorem. So if angle 1 is congruent to angle 3 and angle 1 is congruent to angle 2, that means that angle 3 is congruent to angle 2. And that would come from substitution. Property of equality. Okay, so that's how you would do a 2-column proof. Now, whenever you start doing these on your homework, you may go about it a slightly different way, and that's okay. You don't have to have the exact same steps as the book. Now, if you have a lot fewer steps, that means you're probably skipping too much stuff. And so if you have fewer steps, it's probably not going to work. They are usually going to do it in as few steps as they possibly can. So make sure that yours has most of the same information and you're not leaving anything out. All right, let's look at another one now. We want to do this parallelogram, and angle B is a right angle, and we want to prove that the two lines are perpendicular. So the first thing that we're going to say is our given. So parallelogram JBCK, and angle B is a right angle. And the reasoning for that is going to be given. Okay? From there, what could we say? Since we know it's a parallelogram, that means that this side BC and this side JK are parallel. So BC is parallel to JK. And what else do we know? These two sides are parallel, because that's part of the definition of a parallelogram. Your opposite sides are parallel. So the reasoning here would just be definition of parallelogram. From there, we know that BC has to be perpendicular to BJ. And how do we know that those are perpendicular to each other? Because they told us angle B is a right angle. So that comes from the definition of perpendicular lines. Okay? And if these two are perpendicular, what does that mean about BC and CK? They are also perpendicular. And the reasoning is from theorem 5-6, which says that if you have a line that is perpendicular to one of two parallel lines, then it's perpendicular to the other parallel line. So that's how you can prove that one. You could have these two switched, and that would be okay. It doesn't matter the order on those two. Sometimes the order matters, and sometimes it doesn't. It just depends on what the steps are. Okay, so that's how you're supposed to do two-column proofs. So we're going to go over some practice problems. So I want you to try this one by yourself, and then I'll go over it after y'all have attempted it. So if a triangle is obtuse, what can you conclude about the measures of its two non-obtuse angles? And I want you to justify your answer. So it's not asking for a two-column proof, it's just asking for a sentence explanation, or sentences explanation. So the other two angles have to add up to less than 90 degrees. Because by definition of an obtuse triangle, you can only have one triangle that is obtuse. And an obtuse angle is always between 90 and 180. So since you have your triangle angle sum, the sum of the three have to add up to 180. And if you have one that's 90 or more, then the other two must be less than 90 added together. Okay, so that should be something along the lines of what you said for that one. Okay, we're going to look at this next one. Fill in the reasons for this theorem of 5-5. So one thing to note, whenever it says we're proving theorem 5-5, theorem 5-5 should never show up in any of your justifications. If you have theorem 5-5 on the right hand side somewhere, it's not going to work because you're trying to prove that theorem. So you can't prove theorem 5-5 by using theorem 5-5 in the proof. So nowhere in here should theorem 5-5 show up. So it tells you the information and it asks you to prove. So I want y'all to pause the video and see if you can work through the reasonings by yourself. So for the reasonings, you are going to start off with your given, because that's what they give you first, your given information. So if these two are congruent to each other, then that means that the measure of them are equal. And the reasoning for that would be definition of congruent angles. And again, as you practice these more, as you look at the answers after you've attempted on your homework, you'll start to see more of the reasons. We haven't really used definition of congruent angles before. So as you practice them, it will get a little bit better. For part 3, M in P equals 180. That is the definition of a straight angle. Okay? Then we know that L in M plus L in P equals M in P. And that comes from your angle addition postulate. And then from there, we know that L in M is the same thing as L in P. So instead of L in P, we can put L in M again. And so we would have two of them. And that's from substitution. Property of equality. From there, we can divide by 2 on both sides to get 180 divided by 2 is 90. So division property of equality. And then from there, if this angle equals 90, then the lines are perpendicular, and that stems from the definition of perpendicular lines. So I'm sure most of y'all didn't get every single one of those correct, but hopefully you were able to get a couple of them. So whenever you're doing these, where you're just filling in the justifications on your homework, if you can just get a couple of them right, then that's great. You can try it a little bit, and then if you get stuck, look at the book and look at the first couple of lines, and then see if you can finish the proof from there. These are ones that you definitely have to practice. They're not the easiest kind that you just pick up automatically. They take a lot of work. So Don't give up on these. These are going to be something that are going to be going on through the end of the year. Throughout the book, we're going to be doing 2-column proofs. So you have to work on these. They do take some time to get the hang of them usually. But if you don't give up, people typically are able to get them right in a couple of weeks, or in another month or so, or maybe tomorrow. It just depends on the student. Okay, so let's look at this one. So they give you the information and they want you to prove something. So y'all see if y'all can do this one by yourself. Do as much of it as you can, and then once y'all are finished, y'all can unpause the video and I'll go over it. So the first thing that you want to do is to write your given. And so they gave us that angle ACD is an exterior angle. Of triangle ABC. And so the reasoning on that would be the given. So ACD is an exterior angle. And we're trying to prove the exterior angle theorem, that angle adds up to the sum of the two interior angles. So the first thing that we're going to do is say that these two angles here add up to 180 degrees. So angle BCA plus angle ACD equals 180. And the reasoning here would be that they are a linear pair. So the linear pair theorem. From there, we know that the three triangle angles add up to 180. So the angle of BCA plus the angle of ABC plus the angle of BAC has to equal 180 degrees. And that's by the triangle angle sum theorem. From there, we can substitute. Both of these equal 180 degrees. And so we can say angle BAC plus angle ACD equals angle BCA plus angle ABC plus angle BAC. And that's by substitution. From there, we can cross out the BCA on either side and simplify it. And so we get angle ACD equals angle ABC. I left off my C here. Plus angle BAC. And that's from the subtraction property of equality. And then the last thing to do is just to rewrite it. So this is CAB, if you write it the other way. And then this one is angle ABC. And that's what it had you write. And so the reasoning there would just be the symmetric property of equality, because we had to rewrite it just a little bit. So that's how you can prove your exterior angle theorem. You may have needed more steps than 6. That's fine. You don't have to have the exact same number of steps. But hopefully you had something close to that. Okay, so now we're going to look at the challenge question. So we want to prove theorem 18.1, which says that the sum of the angles of a triangle is always equal to 180 degrees. And it says proof of this line requires an auxiliary line, which they have drawn in for you. So y'all pause the video and give this one a shot. Once you have attempted it, y'all unpause the video and I'll go over it. So for this one, what you're going to want to start with is that we're going to draw line T parallel to EF. And that's from the parallel postulate. So that's the first thing we want to start with. We want to draw that in. So that's not our given. They didn't give us anything. So we can't start with the given because there is no given. Now step 2, we know that angle 1 is congruent to angle 4 because of the alternate interior angle theorem. And we also know, by the same reasoning, that angle 3 is congruent to angle 5. So you can make that a third step if you want, or you can just keep it with the second one. Either one of them is fine with me. But they both have the same reasoning, so you can keep them in the same step if you want. Since these are congruent, the measure of angle 1 has to equal the measure of angle 4, and likewise the measure of angle 3 equals the measure of angle 5. And that would be from the definition of congruent angles. The next step, we could say that the measure of angles 4, 2, and 5 equals 180 degrees. And that's from not a linear pair, because we don't have 2, we have 3, but definition of straight angle. Because together they make a straight angle. And then the last thing that we need to do, angle 4 is the same thing as angle 1, so we can substitute it in. And angle 5 is the same thing as the measure of angle 3. So if you add those all up, they equal 180. And that's what it was asking us to find, that the 3 angles in a triangle added up to 180 degrees. So that's your challenge question. If y'all got that right, awesome job. If not, we have some work to do with 2-column proofs. These take time. Don't stress about it. You will get them eventually, as long as you keep working on them. Your homework tonight is 1 through 30, so make sure that y'all do those tonight so we can go over your questions tomorrow.